Hey everybody, in this video we want to practice working with strings in Python by solving problem number 3, longest substring without repeating characters in LeetCode. So in this problem we are given a string s and the task is to find the longest substring without repeating characters. So for example, for the example that we have here, in the second one, the longest string without repeating character is 1 because if we choose any substring from s, the number of it is only a string of length 1, which is b itself, and a string without repeating character. But on the other side here at the first example, so abc is the longest because as soon as we increase the size of this string by 1, we have a repeating character a repeated in the string. So the way I'm going to solve this problem is to keep track of a string that doesn't have any repeating character. So at each step we keep track of that, starting from the left. So we have a, so we keep track of that, and then as soon as we go to the next one, we just check if the new character already exists in the maximum string that we are keeping track of. So we add b since it doesn't have, and then c again. But as soon as we see a, so this is the time that a already exists in the string. So we just drop a. At each iteration, we keep track of the length of the maximum string, right? So we already handled that, or kept the length of that string already in somewhere in the memory. But as soon as we are inputting a new character and we see that this character already exists in the string, so we dropped that itself and anything left because in this problem you're not looking for a subset, so a substring should be continuous set of characters. So we find a in the string and then drop anything from a and to the left, and then add the new one to the right side of the string. So let's implement that first. So we have a max str. Initially it is equal to empty, and then for every character in s, this is the point that we want to see if the character is in maxstr or not. So one way, the simple way that comes to mind is to check if maxstr dot find the character in, this is the int. But we know that in the problem s only consists of English letters, so it is a constant. Although the length of that it goes to the 10 to the power of 4, but the number of English letters is limited to 26. So if you consider uppercase and lowercase as well, so it would be only 52 cases. So it's still in a constant time, although it might go through so the maximum, the max str shouldn't go beyond 52. The maximum length, or the absolute maximum length for max str is 52. So in worst case, this find would take 52 iterations. So it is still a constant, and it doesn't increase the time complexity, the total time complexity of our problem. So if int is less than 0, or if whenever it doesn't find anything, it returns -1, so that means that's fine. So max str plus equal to, we are adding that to the string, so max str plus equal to c, and then the maximum length, the max length is equal to 0, and then max length equal to the maximum of the max length, the current max length, or the one that we have already in the memory, and the length of the new max str. Otherwise, we should drop that, as we discussed. We should drop, so max str would be equal to the max str anything. So we are dropping anything on the left to the int. So this is the index of the current character, or the character already exists in the string. So we want to keep track of the right hand side, anything after that. So it would be int +1 onwards, plus the new character. And we know this string, this size, is already either smaller or the size would be equal to the max str itself. So that means it has already been checked in the previous iterations, the length of that, so we don't have to update the max length at this time. And I hope that should be enough. So let's try the examples here, the max length. And let's try the second example, which is an edge case. Since it does have repeating characters, it's fine. And this one. So let me submit that. All right, so it was everything for today. So we solved this problem in ON. You might be able to implement it in a more performant way by handling improving this find function that at some cases we might take 52 iterations, by keep converting that into a dictionary. But since it was limited in this case, I didn't go beyond through that way and just use the built-in find function for strings. So that was everything. Hope you enjoyed this video.